welcome to We Chem World. Today we will discuss on the NEET Chemistry 2021 paper solution. So first question is, right option for the number of tetrahedral and octahedral void in hexagonal primitive unit cell. For the general, we know that the number of atom per unit cell is equal to the number of octahedral voids. So number of atom per unit cell, this is given is the hexagonal. And we know that the number of atom per unit cell in hexagonal is equal to the 6. So n is equal to 6. And this number of atom is always equal to the number of octahedral voids. So octahedral void is equal to the 6. And tetrahedral void is always twice than the octahedral voids. So tetrahedral void is equal to the 12 because of the tetrahedral void is twice than the octahedral void. In this question, for number of tetrahedral and octahedral void. So first tetrahedral void 12 and octahedral void is 6. So right option is the D. And you see that this is the 8, 4, 6, 12. So this is the wrong answer because of the tetrahedral void is always twice than the octahedral void. And this is the 2 and 1, but in this given is the hexagonal. So right option is the 12 and 6. Second question, zirconium and hafnium have similar atomic and ionic radii. Because of we know that in the periodic table, this is the zirconium and hafnium present is the D block element. And between this zirconium and hafnium, lanthanide seed is present. Where lanthanide seed is present, so it shows the lanthanide contraction. Lanthanide contraction present, that way its atomic and ionic radii is same. So its right option is the lanthanide contraction. Third is for a reaction A to B, enthalpy of reaction is minus 4.2 kilojoule per mole. Complete enthalpy of reaction, that is enthalpy of reaction delta H is equal to the minus 4.2 kilojoule per mole. We know that the delta H is negative, that means this is the exothermic reaction, and where this is the positive, so this is the endothermic reaction. But in this question, this gives the minus 4.2, so this is the exothermic reaction. And enthalpy of activation is 9.6. That means the activation energy graph size or potential energy is more than this product value. The correct potential energy profile for the reaction. Exothermic reaction means the energy release. For the reactant A and product B, in the form of the product B, energy is released. Where energy released, so its energy amount is decreased. So for graph, this is the AB. So A value is a decrease than the B. So this is the not right option. Given is the exothermic. So product value, product energy is decreased. Second graph, this is the reactant and this is the product. In this case, product energy is decreased. Third, A and B. This gives the same value of the potential energy. So this is the not right. And for A and B, this B is more energy than this reactant. So right option is B because of the exothermic reaction. In the exothermic reaction, product energy is less than the reactant. 54. Tritium, a radioactive isotope of hydrogen, emits which of the following particles? First of all, the tritium. Tritium is 1H3. This is the isotope of hydrogen. It emits beta particle, gamma, alpha or neutron. This is the textbook example. 1H3 converted into 2H3 and minus beta 0, electron 0. So this is the emit beta particle. Next is the RBC deficiency is the deficiency disease of the vitamin B12. Next is the 56. The molar conductance of NaCl, HCl and CH3COONA at infinite dilution are 126.45, 426.16 and 91 Siemens centimeter square mole inverse. The molar conductance of CH3COOH at infinite dilution. So given value is the molar conductance of NaCl. This is the lambda NaCl. This value is 126.45 Next is the HCl. This is the 426.16. And third is the CH3COONA is equal to 91. Then find out the molar conductance of the CH3COOH. CH3COOH. How to find out it? So first reaction, this is the CH3COONA plus HCl converted into CH3COOH plus NaCl. So this is the reaction and we find out the CH3COOH. How to find out this two value CH3COONA plus lambda HCl minus this value NaCl is equal to this lambda CH3COOH. So this value given is the 91 plus lambda HCl is equal to 426.60 minus NaCl value. This is the 126.45. So this is the answer for this, the molar conductance of CH3COOH at infinite dilution. So its answer is the 390.71. And the correct structure of 2,6-dimethyl DEC4-in. DEC means 10 and in means double bond. This is the 4-in. So 4 number carbon is present is the double bond. 2,6-dimethyl. So numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So DEC means 10 carbon present. Then check 2,6-dimethyl. So this is the 2-methyl and this is the 6-methyl. Methyl group present. And next is the 4-in. So 1, 2, 3, 4 and 4 double bond 4-in. So its right option is the 1. 2,6-dimethyl DEC4-in. Next is the maximum temperature that can be achieved in blast furnaces. This is the direct NCERT book question. This is the up to 200 Kelvin, up to 1900, up to 2200 and up to 5000 Kelvin. In the book given is the 2180 Kelvin. So nearby this is the value of the up to 2200 Kelvin. So this is the right option. Next is the identify the compound that will be react with Hinsberg reagent to give a solid with dissolved in alkali. This Hinsberg reagent present with the amine. For the first degree amine, it gives the reaction and dissolve in alkali. Next, second degree, this gives the reaction, but this is the not dissolve, means insoluble in alkali. And third degree, this is the not react. So find out the Hinsberg reagent. This gives the first degree and 2 degree. Then next given is the which is the dissolve in alkali. So dissolve in alkali is always the primary, means the first degree amine. So this in this case first degree amine. This is the second, first and third. So this is the right option is this. 10 gram of glucose in 250 ml of water. This is the P1. 10 gram of urea in 250 ml of water. This is the P2. And 10 gram of sucrose in 250 ml water. This is the P3. Then find out the osmotic pressure of this solution. So that we know that the pi is equal to ICRT. This glucose, urea and sucrose is not dissociation. So this is not depend on the I factor. So remaining factor is a pi is equal to CRT. R and T is a constant. So pi is directly depend on the concentration. Where concentration increase, so pi value is increased. And we know that the concentration is equal to the numbers of mole dissolved in per liter of solution. So concentration is equal to the numbers of moles per liter of solution. So volume of solution in liter. But in this case 250, 250 and 250. So volume is same. So that way the concentration is directly proportional to the numbers of moles. How to find out that moles? So moles N is equal to the weight upon molar mass. For these three weight same 10 gram, 10 gram and 10 gram. Only difference for this molar mass. You find out that this all molar mass. So N1, N2 and N3. This is the 10 divided by the glucose 180. Then next 10 divided by the 60 and then 10 divided by the 342. For so that the N is equal to the divided by 180. Next is the 10 divided by 60, where this value is decreased. This value is decreased, so mole value is increased. Whereas this value is increased, so mole value is decreased. So highest numbers of moles is the N2, then this N1, and the next is the N3. This 3 is directly proportional to the concentration, and concentration is proportional to the osmotic pressure. So this is same value is the P2, P1 and P3. So right option in this case P2, P1 and P3. So first is the right option. Next is the major product of the following chemical reaction is, this is the alkene and HBr. Alkene react with HBr, it's follow Markov-Nikov rules. Where in the Markov-Nikov rules, this is the highest degree connect with the Br and lowest degree connect with the hydrogen. But in the presence of this is the peroxide. With the peroxide present, so it's follows the anti-Markov-Nikov rules. In the anti-Markov-Nikov rules says that this is the lowest degree connect with the Br and highest degree connect with the HBr. So in this case CH3CH, this CH connect with hydrogen and this is the CH2Br. So this is the right option 1 because of the anti-Markov-Nikov rule. Next is the aspirin and paracetamol belong to the class of narcotic analgesic, and morphine and heroin are non-narcotic analgesic. We know that the aspirin and paracetamol belong to the non-narcotic analgesic. This is the non-narcotic analgesic. And morphine and heroin is the narcotic analgesic. So this is to the alternate. So this is the wrong and this also wrong. So its answer is the both statement 1 and 2 are false. Right option is correct sequence of bond enthalpy of CX bond is, it gives the enthalpy of bond where bond strength increase, so enthalpy of bond is increased. In the smallest size overlapping is more, so its bond length is decreased and bond length decreased, so its strength is increased. So in this option smallest size is the CH3F. So in for 3 option this is the cancel. 3 option first is the smallest size is the F. This is the highest bond strength, its enthalpy is the highest. Then the chlorine, bromine and iodine. So lowest enthalpy is CH3I. So its right option is the CH3F, CH3Cl, CH3Br and CH3I. Next is the BF3 is the planar and electron deficient compound. Hybridization and number of electron around central atom respectively. First to find out that the hybridization. We know that the hybridization of the BF3. Consider this is the valence electron. This valence electron is 3. And fluorine, so this is the 1. So 3 plus 3 is equal to 6. 6 by 2, this gives the 3. 3 means sp2. So its hybridization is sp2. In this case, this is the sp3. sp3 cancel out. Only sp2 hybridization. And then given is the electron deficient. Electron deficient means the electron present less than the 8. So in this case, sp2 hybridization and electron present in this case 8 and in this case 6. So right option is the sp2 and 6. Next is the which among the following is the correct option for right relationship between Cp and Cv for 1 mole of ideal gas. This is the basic question. This gives the answer is the Cp minus Cv is equal to R. And for n mole, so Cp minus Cv is equal to Nr. In this question given is the 1 mole. So Cp minus Cv is equal to R. Next is the among the following alkaline earth metal halides, one which is covalent and soluble in organic solvent. We know that the covalent nature is directly proportional to the size of the cation. So covalent character is directly proportional to the size of cation. Where size of cation is decreased, that means the covalent character increase. Where covalent character increase, so its solubility increase. So in this case, this is the calcium chloride, strontium chloride, magnesium chloride and beryllium. This is the beryllium. In the beryllium, 1s2, 2s2. So this is the only n is equal to 2 value. When n is equal to 2 values, so this orbital and nucleus is come closer. So its size is decreased. Where its size is decreased, so its covalent character increase and solubility increase. So this option, right option is the beryllium chloride. Compound contains 78% carbon and remaining percentage of hydrogen. The right option for the empirical formula of compound. First find out the percentage of hydrogen and percentage of carbon. So carbon and hydrogen. Percentage of carbon given is 78%. And hydrogen, this is the 100 minus 78. So this is the 22%. Then next, given is the atomic weight of carbon is 12 and hydrogen is 1. So divide this percentage by this atomic weight. So this is the 78 by 12 and this is the 21 by 1. This answer is a 22 and this gives the 6.5. This is not present in this formula. So it's converted into integer number. How to convert it integer number? So divided by the smallest value. This is the smallest value 6.5 and this is divided by the 6.5. So this gives the 1 value and 6 3s are 18.5. So this is the 1:3 ratio. So its empirical formula is CH3. So right option is CH3. Next is the major product formed in dehydrohalogenation reaction of 2-bromopentane. Given is the 2-bromopentane. So this is the 1, 2, 3, 4, 5 and this is the bromone. 2-bromopentane. Dehydrohalogenation converted into pent 2 in 1, 2, 3, 4, 5. Pent 2 in. This product formation is based on the Sedgwick rule, Hund's rule, Hofmann and Huckel's. This is the aromaticity for apply aromaticity, Huckel's rule. This is the Hund's rule. This is the 1s2, 2s2 for the electron occupying orbital. So consider only two, Sedgwick rule and Hofmann rule. And in this given is the major product. And major product always gives by the Sedgwick's rules. Next is the what is the IUPAC name of organic compound formed in the chemical reaction? First given is the acetone. So acetone is the CH3COOCH3. Then react with C2H5 MgBr dry ether and H2OH+. This is the Grignard reagent. So given this C2H5 MgBr. This C2H5 is the minus charge. And C double bond O, C is the positive charge. So this minus is attack on this oxygen. So nucleophile attack on this electrophile. It's converted into CH3, C. This is the double bond. So for the stability, it's converted into minus 1 bond. And this is the react with C2H5 and CH3. Next, hydration H2O, H plus. So H2O, hydrolysis, CH3, C2H5, OH and CH3. So this is the product. So find out that the product, this given is the product. 2 carbon, so 1, 2. This right is the C2H5, C, CH3, OH and CH3. So this is the 2 carbon. So 1, 2, 3, 4. 4 carbon is present. 4 carbon means butane. So in this case, propane 2 ol cancel, pentane cancel, pentane cancel and methyl butane 2 ol is right. But in this case, lowest group in this case, so this is the C2H5, C, CH3, C2H5 and OH. 1, 2, 3 and 4 number carbon. So this is the 2-methyl 2-butanol, 2-methyl butanol. Next is the noble gases are named because of their inertness towards reactivity. Identify an incorrect statement. So first, noble gases are sparingly soluble in water. Yes, this is the right. Noble gases are sparingly soluble in water. Then noble gases have very high melting point and boiling point. Melting point and boiling point depend on the strength of the bond. In this case, weak strength of the bond is weak, so its melting point and boiling point is low. So this is the incorrect statement. Then noble gases have weak dispersion force. Yes, this is the right. Noble gases have large positive value of electron gain enthalpy. Yes, because of this is the completely filled orbital present. So completely filled orbital present. So it's except electron, it's require large enthalpy. Of dimethylamine and pKa of acetic acid are 3.27 and 4.77. The correct option for the pH of dimethyl ammonium acetate. Dimethyl ammonium acetate, this is the buffer solution. So how to find out the pH for this buffer, and given value is the pKa and pKb. So write the formula. pH is equal to the 7 plus 1 by 2 pKa minus 1 by 2 pKb. This is the 7 plus 1 by 2. pKa value is 3.27 minus 1 by 2 pKb value is 4.77. So that way this total value is the 7.75. Only write this formula and put this value. Given answer is the 7.75. Next is the right option for this statement. Tyndall effect is exhibited by. Tyndall effect shown in this colloidal solution. So first you write that what is the colloid solution. This is the NaCl solution, this is the not colloidal solution. Glucose solution, not urea is the not colloid solution. Only colloid solution consider is the milk and the starch. In this case, starch is present, so this right option is the starch solution. Because of this is the colloid solution, and colloid solution gives the Tyndall effect. Next is the acid strength increase in the order of given is the HF, HCl, HBr and HI. We know that the acid strength increase. How to acid strength increase? So this is the HF, HCl, HBr and HI. This size is more in this group: fluorine, chlorine, bromine and iodine. Iodine size is more than the fluorine. Where is the size is more? So its overlapping is less. Where overlapping is less, so its bond strength is decreased. Where bond strength decrease, so it's easily remove H plus. Acid is the easily remove H plus. In this case, acid is the easily remove H plus. Where easily remove H plus, so its acidic strength is more. So this is the right option: HF, HCl, HBr and HI. Then next is the size of the element FCl, Bri increase down the group, bond strength of HF, HCl, HBr, HI decrease, and so acidic strength increase. Yes, this is the right option. So both statement 1 and statement 2 is right. So both statements are true. This is the option 1. Ethylene diamine tetraacetate EDTA ion is. First of all, the formula of the EDTA, this is the ethylene diamine, CH2, ethylene diamine, tetraacetate, COOH. This is the acetic acid and convert it into acetate, so remove H. Then first option is the hexadentate ligand with 4 oxygen and 2 nitrogen donor atom. Monodentate, bidentate, tridentate and hexadentate. In the monodentate means the only one ligand donate electron pair, bidentate 2, and same way hexadentate means 6 for oxygen and 2 nitrogen donor atom present. So in this case 1, 2, 3, 4 for oxygen and 1 nitrogen, 1 and 2. So 2 nitrogen atom present. So this is the hexadentate ligand. This is the right option is hexadentate ligand with 4 oxygen and 2 nitrogen donor atom. Next is this, choose the correct option for graphical represent of the Boyle's law which show the pressure versus volume of gas at different temperature. We know that the P is directly proportional to the temperature. When pressure decrease, temperature decrease, pressure increase, temperature increase. And this is the pressure versus volume. P is inversely proportional to the 1 upon V. So this gives the hyperbola of the graph. So this is the linear, this cancel out and this is also cancel out. This 2, in this 2, this is the pressure decrease, pressure and this pressure increase. Where is the pressure increase? So temperature decrease. Pressure increase, temperature decrease. In this case, pressure increase, temperature increase, pressure decrease, temperature decrease. This is the inversely proportional to the pressure and temperature relationship, and this is the directly proportional to the pressure and temperature relationship. So right option is the P is directly proportional to the temperature. So this is the right option 4. Next is the structure of beryllium chloride in solid state and vapor phase are. In this beryllium chloride, BeClCl. In the solid state is form this chain and vapor form its dimer. So right option is the chain and dimer. Next is the which one of the following method can be used to obtain highly pure metal which is a liquid at room temperature. Liquid at room temperature, this is metal is the mercury. For the Zn, mercury and cadmium, this show this distillation process. So this right option is the distillation. Only key point is the liquid at room temperature. Liquid at room temperature is the mercury. Next is the compound which show metamerism. Is in the metamerism two different functional group present. For this hydrocarbon, this is the not functional group present. This 3 is 1, 2, 3. So metamerism in this 3 carbon, one for example 1 C double bond also one side CH3 group and one side CH3 group. So that way this is the only one configuration. But in the presence of the C4H10O, it gives the two configuration, different configuration. So this right option is the C4H10O. Next is the correct option for the number of BCC unit cell in all 14 types of brevis lattice unit cell. In this 14 unit cell, 7 primitive unit cell, 2 end center, 2 face center and 3 brevis lattice. Means ki BCC body center cubic. So its right option is the 3. Of the following polymers is prepared by addition polymerization. Polymerization divided into two: addition and condensation polymerization. This given is the addition polymerization. We know then that this is the Teflon. Teflon is CF2 double bond CF2. It's converted into CF2 and CF2. So this is the addition polymerization and all three are this condensation polymerization. So right option is the addition polymerization is the Teflon. Next is the which of the following reaction is the metal displacement reaction. Metal displacement reaction means the more reactive metal displaces the less reactive metal. So first is the KClO3 converted into KCl and plus oxygen. So this is the decomposition reaction. This is the cancel out. Next is the Cr2O3 and aluminium. So chromium is replaced by the aluminium. So this is the replacement reaction. Next is the Fe plus Cl converted into FeCl2 plus H2. No, this is the not right option. And 4 is the PbNO3 twice PbO plus N2NO2. This is the decomposition reaction. So this is the wrong. So right option is the Cr2O3 plus aluminium converted into Al2O3 plus 2Cr. This is the displacement of the metal. A particular station of All India Radio, Delhi broadcast on frequency. So frequency given value is 1368. This is the kilohertz converted into hertz. So multiplication with 10 raised to 3 hertz. The wavelength of the electromagnetic radiation emitted by the transmitter. So find out the lambda value. We know that the lambda is equal to C upon mu. The C value is given is the 3 into 10 raised to 8 and upon V value is 1368 into 10 raised to 3. This gives the lambda value in meter. So its right option is the 219.2 meter. The incorrect statement among the following for this actinide and lanthanide series. Actinoid contraction is greater for element to element than lanthanoid contraction. Yes, this is the right because of the actinide is below than the lanthanide. Next is the most of the trivalent lanthanide ion are colorless in solid state. This is the wrong because of the most of the trivalent lanthanide ion in colors. This gives the colors in solid state because of the unpaired electron present. Unpaired electron present. Third, lanthanoids are good conductor of heat and electricity. Yes, because of the unpaired electron. Actinoids are highly reactive metal, especially when fine. So right option is the 2. Most of the trivalent lanthanoids ion are colorless in solid state. Next is the dihedral angle of least stable conformation. More stable conformation. For example, this is the staggered and eclipse conformation. So this is the CH3 and CH3. Hydrogen, 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 hydrogen. So this is the 180-degree dihedral angle. So its stability is more. Where bond is decreased, this two bond is decreased, so its stability is less. That way least stable means bond is less. Bond less means the stability is less. So this is the right option 0. This is the fully eclipsed. fully eclipsed structure because of the in between these two bonds is the angle is 0. So this is the least stable. Next is the match list 1 and list 2. PCl5, SF6, BRF5 and BF3. First find out the hybridization. For the PCl5, central atom 5 plus Cl, 5 divided by 2, 10 divided by 2, this is the 5. Its hybridization is sp3d. When sp3d, so its structure is the shape is the trigonal pyramidal. So first, this is the 4. Then next, SF6. Central atom electron is 6 plus fluorine 6. So 6 plus 6 divided by 2, 12 by 2. This is the 6. Its hybridization is sp3d. sp3d2, its shape is the octahedral. So B is the 3. Next is the BRF5. And third is the BF3. First BRF5. Br is 7 plus fluorine 5 divided by 2. This gives the 6 sp3d2. For this sp3d2, SF6 and BRF5. BRF5, so one lone pair present. In this octahedral, all occupy space. But BRF5, one lone pair present. So this gives the square pyramidal structure. So third is the 1 and fourth is the